Hey guys, welcome back to Jack on Tracks. And in this episode, we're going to install these panels into the cutouts that we had, and we're going to wire them up. All right. So it's all a little bit new to me because I've never wired these before. So here we go. This should be fun. The loco net is going to get done later. I still have to figure out all the stuff for that. So we're basically just putting that in there like that. I looked around to try to find the right size, see if I had the right size screws here, and I didn't. So I wound up going to the store and wound up buying a set of 5 by 1/2 inch. I could have went a little bit shorter, but these are the only ones I had 2-pack of at the Home Cheapo. And that store sucks. All right. I like to get one in. I'm going to come back at a later date. And I'm going to countersink these in. Now, I did my best to get these holes as tight as possible. And I really didn't do that good of a job because these bottom screws are like, you see, they're going in like an angle because the hole is a little bit too big. Mind my head, sorry. All right, because, I get crazy. Now I'm getting crazy. All right, where's my, I had like a little bullet level. I can't find it. No. We're sending it. As you can see, the holes don't line up right. They're a little wide on the bottom. Really nothing I can do about that. That's just the way I got all this together. So when I come in at a later date, I'm going to come in at a later date and recess this in so it's flush with the face. I don't have to. It'll just look nicer. So basically, guys, that's how you install it into the fascia. I'll do another video later on when I come in, and I'll take a chisel. I'll chisel around this, get a nice edge around it, line around it, and I'll come in, clean this out, and recess this in. But we'll do that at a later date. All right, let me get the other 4 panels in, and you don't need to watch that, and we'll go from there. All right, guys, so here we are. We're at the table. So basically, what I need to do is I need to go from AC, which is the power bus, auxiliary power bus, to DC, which is the which powers the DCC panels, powers the turnout, the tortoise switches, and the signals on the tortoise switches. And it's also going to power, I believe, the lights for the buildings. Not 100% sure of that because I do use the just plug lights, and I believe I can do those on AC as well. But I'm probably going to do the same thing because it's just easier for me to just connect to a terminal than it is me to cut into the wire and stuff like that. We'll figure the lights out when it's time to figure the lights out. Right now, we're going to build one of these. I'm going to show you how I do this. All right, there's a Bojack bridge rectifier, part number KBPC2504. It's 400 volts, 25 amps. All right. In other words, we ain't going to overdo this one on this layout. I purchased a set of these are bridge rectifiers, and this is a bridge rectifier as well. Okay, let me open this up and I'll show it to you. All right, so this is a bridge rectifier with capacity. It's a bridge rectifier with a filter on it, which is those two. So one of these two is the filter, capacitor filter. So this is the adjustment. You can adjust this up and down. I didn't know this, and I just learned this, and it explains why I blew something up building a Keep Alive. All right, so if you got say you got 16 volts AC coming in, you can have up to 32 volts DC coming out. Most likely not going to be that high, but it's going to be probably in the 20s. I'll show you on my meter when we're all done. I also purchased a bunch of these. Now, this is a DC to DC converter. I know they call it a converter, but it's basically adjustable. So that's what these are for. So I'll have 16 volts here, AC, going into here, coming out DC at whatever the voltage is supposed to be, is coming out at. And then I can adjust it with this screw, and it tells me on this panel what I'm going to. So when I bought these, I was all set to go with these, and no problem. I'll just set it with my voltage meter and whatever. And then I saw these. I'm like, yeah. And these weren't that expensive either. I'll put the price of everything in the comments below. I got all this off of Amazon. I believe I got these all off. These I know I got off of Amazon. I believe I got these off of Amazon too. I might have got these off AliExpress, but I'll leave the information in the description. So, right, basically AC in, DC out. AC in, DC out, DC through here. The capacitors are the filters, and then comes out here, and I can adjust the voltage to tell you where it's supposed to be. So this is really simple to do. So I'm going to get to it. So there's going to be the stretcher wires between these two. Actually, you know something? I'm going to leave that. I want them a little bit longer. I'll go 8 inches. All right. So this is old Radio Shack rosin core solder. Okay. For doing what I'm doing here, that's fine. If you want to go in and you're going to start doing any type of soldering with any type of like real electronics, like soldering onto this board with any real electronics, you want to use this Chip Quick stuff. And I use all Chip Quick fluxes. All right, this is like the no wash stuff, or whatever. But usually, if I'm doing a decoder, I take isopropyl alcohol and I give them a quick cleaning with the isopropyl alcohol. So we got to solder onto this. I could put a drop of that on there, or be a little neater, I got a flux pen. That's from Chip Quick too. I recommend it. And the reason why I use Chip Quick is because the guys at Soundtracks basically told me that that's what they use and that's what they recommend. And since I had to send a couple of decoders, I sent 2 decoders back to them that I screwed up because I used the wrong flux. And what happened was the flux fed under the amplifier and smoked the amplifier. All right, so if you look at the tip of my soldering iron right now, starting to get all black scotchy on there. All right, that's from the rosin core solder. Here, I'll use this. This is the chip quick stuff. Watch, this doesn't, I don't remember getting any, it's so stupid. I don't know why I do that, but I do it. When you look at this rectifier, it says AC positive. All right, so this is the way this is set up. That's AC, that's AC. That's the positive DC, that's the negative DC. Am I sure? I'm sure. So we're gonna go in here and we're gonna solder this in. I soldered the reds on the same side. It says AC and positive. I put the reds next to each other. All right, so that's that. Now I need two more. Got the AC coming in and DC going out. So I have over here my trusty Atlas power pack. We'll go on to AC. All right, for some reason it says putting out 19 volts AC. I think the battery's going dead in this. So it's giving a bad reading. All right, so even if it is 19, all right, 19 even. Okay, so remember those are the out, these are the in. All right, so the AC in is 19. And even though it's still saying AC, it's showing it's at 36. And I don't know, something's going on with my thing. All right, so let's turn the power off. So I can only tell you what they told me. They told me that it'd be too high. I need to step it down. Whatever it is, doesn't really matter. All right, negative, positive. And I do believe the battery is going dead in this because this thing loves to give bad readings when it's the batteries are low. All right, power's on. Showing 24 volts in. And that's showing 24 volts out. All right. 24. Okay. I don't know what happened. Maybe my meter, maybe the diode needed to warm up a little bit. Not 100% sure. Now it's showing 24. All right. So basically, I think this thing needs to get a little warm. It's not even warm to the touch. So I'm not gonna have a problem with overheating because it's 400 volts, right? That's what it said on there, 400 volts. So we have plenty. All right, so that's power in, that's the power coming in, that's the power coming out. So this is a little, I guess we call it dash pot maybe, potentiometer, whatever. So just turn in, things start moving. There we go. Let me turn it around. It might be upside down to you, but my big fingers are in the way, so. It says 15. Now, like I said, this is a cheapo one. and I think the batteries are going dead on it. So this is the outside, negative, positive, 14.7. That says 15. That's close enough to me. So that's how we build this circuit. All right. Now, basically this one, let me throw a couple of wires in here for you. Actually, I don't even have to throw wires in there. All right, so I got power there. Okay, no rectifier, just a straight power. And it comes through. And I'm getting 7 volts. There, turn it up. Same thing. Now, this is perfectly fine. I could have went with that. I decided to go with the one that has the readout on it. Okay, that's just for me. This is a module. It's going to go to shows. I'm going to be hooking up the different power units, and this just gives me the ability to pop my head underneath and be like, oh, all right, it's running a little cold. I can turn it up a little more juice. And if they're running for some reason 20 volts, I can turn this down if I'm getting too much. This one, I would have to get a meter out and everything else. But if you're doing this on your home layout, all right, it's your home layout. Just put this in and you're done. You know, that's fine. That'll work perfectly fine for home layout. Yeah, there's no, there's really nothing you would have to, for a home layout, this is fine because it's not, your voltage isn't going to really be changing. This is cheaper than this because I had to buy this, and these aren't cheap. I think this was like $7 for 2. It'll be in the description. So let me just let me add my wires over here, and we'll go from there. All right, guys, here we are with this is the 3rd one being built. I don't know what happened at the end of building the other 2. I just lost it. The quality went. So basically, I got this set up. It's all wired in. It's all wired together. Got 24.7 volts coming in. 8 volts coming in. 24.7 going out. Turn the pot in. Crank it down. 15.1. 15. All right, so we're pretty much done at this workbench for now. So we'll go over the other one. But like I said, what it cost me for this one, this style, was the same per piece for this style. But this board, you need a rectifier with. This is a heavy dude. This is overkill for a rectifier. You could probably go with a smaller one. I just found these and I like them. Nothing's ever going to come close to maxing this out. So, like I said, for your home layout, these would work fine because you got to set them and forget them. And it's going to be running off your same power unit over and over again. You're not going to be changing them. This going to clubs and stuff like that. You could have an auxiliary power that's too high, and you'll know. You don't have to bring a meter with you. All right, guys, let's go put these in the on the modules. All right, guys, so we're back from the workbench. I showed you how we built this. I just plug this in, positive out, negative out. All right, so getting all this wired in. All right, so what I picked up was these standoffs. To just get these plastic standoffs was the same price of getting this kit. So I got the kit because I would have to go figure out the screws and stuff like that, and I didn't feel like wasting the time doing that. So this saves me time, and it was actually probably cheaper. All right, how big are these? Nope. All right, so you saw how I built this. Just previously saw how I built this. So these standoffs, even though these are a little tall, they're 20 millimeters. I believe, I hope these are the right size. That would suck if they weren't. All right, so these are actually really tall. These are like 20 millimeters. I mean, it's going to be standing off the bottom of this a lot. It doesn't need to be, but it was cheaper to buy this set than it was to buy 10 millimeter ones and then have to go buy screws for it. Because I wouldn't be able to screw it to here. I'd have to screw it over there because I couldn't. That's the top. So this works out a little better. No, let me show you what these do. They're basically little feet that this thing's gonna stand up on. You want to be real fancy. You can turn these so they're in the middle like that, and you can't see them. But I mean, I do have the OCD. So it'll probably drive me a little crazy, but for ease, just doing it this way. So this is gonna get 4 of them. Reality, I can probably, I don't know if this is long enough. This is not long enough. If these were long enough, I could have did one. I could have did one holding this up, but I'm not going to. That's gonna get screwed right here. I want it there because, like I said, I don't have the ones that are long enough to do what I want them to do. I don't know where they went to. So you get the legs on this. I paid like $8 for this kit delivered, and it's like 100 of these. So I'm going to have 20 millimeter standoffs for a long time. And you'll see some of these that they're metal. The standoffs are metal. Just buy the plastic ones. Even though the metal ones might sound like a better idea, not. You could possibly short something out. It's not worth the aggravation. So if I believe if I wanted to, I could have soldered my wires onto these, but I prefer not to do it that way. The only issue I'm having is the only issue I'm going to have with this is I have to put a block here to run the power to this side. Okay. The only problem I have is I didn't pre-wire these, so I don't have a screwdriver short enough to get in here. So we're gonna have to take this off and run the wires that way. Not a big deal, just something to remember when you're putting these in. Once again, the reason why I went with this board over the other board, I bought 2 types of these. This is actually a DC to DC, and then this is the rectifier. The other one was a rectifier built onto the board that you could adjust it, but it didn't have a readout on it, which I think is going to be beneficial when I'm at a show and and if the voltage, if they have a different higher voltage, I can crank it down a little bit, or crank it up if I need to. All right, so we'll get these hooked up to here. Get that soldered in, and then we'll run these over to here. So I'm gonna use these cutoffs to make jumpers for here, so I can get power to this. Right now there's nothing else on here that needs power. I'm probably going to have to come back in here and revisit this and add more to this because there's going to be lights on here later on But right now, I'm just trying to get everything. I'm trying to get this thing basically wired up so that I can get this to the show. All right. Someone already made mention to me that I have this wired incorrectly for signals, and I have to look into that. I'm not planning to put signals on this thing at this time, but I think what I have to do is I have to separate all these. I have to separate. This is the feed. I have to separate all these pickups. I have these pickups all soldered together, all nice and neat. So everything went in a bundle. I'm just going to have to make a longer strip of these and have each one of these going into each one of those. So, but that's basically it. Then that, as far as my understanding is, that's where my mistake is. So we'll correct that at a later date. Right now, I just want to get this wired in. Like I said, I'm going to have to flip these over. I'm going to have to take these out to run the wire down to there. That's just the way it is, because it's just the way it is. So, all right, let me, what do I need to get? Oh, I need to get my strippers. I'll be right back. I don't have to, right now, my strippers in there. All right, I'll be right back. Busting out my trusty old Weller. Now that I have a nice soldering station, it's hard to believe that I did all my DCC installations with that gigantic tip. When I get a chance, I'm buying a soldering hood. This the other day, I did a decoder install for somebody, and I was coughing like crazy afterwards. I got enough to go there. I'm going to get a piece right there. All right, so give me a minute. I'll be right back. Like I said, I got to pull these out again and connect the wire to them so I can run down and pick it up. And I'll show you that. All right, guys. So I'll be right back. All right, guys. So we're back. I took this top one out, and we're gonna wire it up. All right. This is supposed to be 20 AG wire, which I believe is heavier than what they call for. I think they call for 24. I think I use 20. Or it's 20 and I use 20. All right. So, all right. So as per the instructions, ground and track power. Okay, so this is these are power in, power out. That's the ground, that's the track power. That's for positive. So I like to tin these. Okay, this is what I'm gonna show you why I tin these. I find it hard to push these in if they're not tinned. So I tin them. A little extra step. The only thing I don't know how to do is I'm not sure how I got to wire into this. So that's basically where I'm at. They said there's a DCC bus. I don't know how that works. I gotta ask questions about it. Like I said, I've never done this before. This is the first time I've wired these in. I've used a Sprague before, and my whole layout is 4 foot. So I plug it in one end and it goes. So gives me a little peace of mind. And I'm a little neat. neater under here. Nice and neat, right? So basically I gotta pull this off of here, and then I gotta do the same to here because I don't have a screwdriver small enough to get in the back there. Here's a small screwdriver I have, and it's not small. So yeah, but we can pretty much figure out the wire that goes there, because it's not really, it's basically this. No, it's actually not. Gotta be a little bit longer. That's what we'll do. So I'll pull this out and I'll get it in there. I'll hit this with a little liquid electrical tape and seal that up, and that'll be that. These two I can tie those together. Nice and neat. All right. So got everything pretty neat in here. That's all that. I'll touch that with liquid electrical tape, and I'll wire this in. But basically, you guys saw basically how it gets wired in. The ground comes in. Excuse me. Ground comes in on one side. The power comes in on the other, and then the two tracks A and B. So I just have to figure out how I get this into the track, because that's what I don't understand. That's what I don't know what I got to do. I think I just got to put one of these into here, or I'll have to wire them all into there. I'm not 100% sure, because they're all hooked in with LocoNet. So I'll look into that. All right, guys. So I'll be right back. All right, guys. So here we are. Pretty sure I got this thing wired, functioning. Maybe not 100% correct for doing signaling, but I'm actually, if I decide to do signaling, I'll come back in, I'll redo this main bus, because that's the one that I think is a little messed up. I'm not really supposed to have everything going into one junction block like that. I'm probably going to redo it, but right now, just to get this thing up and running, I'm pretty much done. So I got the lead off of the main bus coming into this block here, feeding both tracks, all three tracks actually on here, and then another lead coming over to here, which is then giving the track status feed to the two UP7s, which is getting power through this bridge rectifier into this DC to DC converter to lower the voltage down to 15 to 16 volts. Into this block here, power runs into here, to the UP7, runs down across here to the bottom UP7. And then that's pretty much it. Got all the power pole connectors in. I have the single line in for the DCC booster. That's in here. And I know it's a different color, but deal with it. I'm not cutting up friggin' wire, because I actually don't have any to do it. Basically ran out of wire. So I got that in there. And I have to go do the other two modules, which will be pretty much the same way, except the center module, which has the tortoise switches on it and the lights. But that won't be a problem. It's just going to be another block like this in here with another split, a couple more splits on it. But that's about it. All right, guys, thanks for watching Jack on Tracks. Like and subscribe. Any of you Fremo guys see something that I did wrong, just put it in the description. I know someone mentioned something about best practice, but the problem is you guys don't have a list of best practices. So, or I can't find it. If you have a list, put the link in the comments, and I'll go through it and read it and make any other corrections. I understand that this probably isn't the best practice, but it is what it is right now, and it'll be functioning. It'll functional for running trains on it. So, yep. And then when I'm all done with this, I'll give you the lessons learned on it. I learned on doing the Fremo and the wiring, because I'm not really that good on wiring. I try to keep it as neat as possible. I know this over here looks like a spaghetti mess, but that's the way it is. But the rest of everything is as neat as it's going to get. So, all right, guys, thanks for watching. Like and subscribe. Hey, listen, hit that subscribe button. We're doing a giveaway. You got to be a subscriber, and you have to watch the videos for the build, and there'll be key clues in the video on how to win it. So, again, thanks for watching. Thanks for putting up my shenanigans, my nonsense, my probably cluelessness on some things. But like I said, I'm just a guy playing with trains, learning new things. All right, guys, as always, catch you later.